I want to show you some of the videos to expect in the upcoming months. I'm going to be doing video lectures for the Physics 2 and eventually for the Physics 4 class. 13 will be the first one coming up, and it's about universal gravitation, Kepler's law, Newton's law, gravitational potential energy, and satellite motion. So once upload these, you can search for them by putting quotes Kiledjian and chapter 13 unquote, finish the quote, and then search, hit the search button. So then I go to chapter 14. Once I do that, you should be able to search by that chapter as well. Chapter 14 will include topics such as fluid mechanics, pressure, buoyant forces, Archimedes' principle, Bernoulli's equation, and then comes chapter 15, but I've already done chapter 15, that's oscillatory motion. So let's skip that to chapter 16, which is wave motion, propagation of a disturbance, sine waves, speed of waves on a string, reflection and transmission, rate of energy transfer, and the wave equation. The next one, chapter 17, would be speed of sound waves, periodic sound waves, intensity of periodic sound wave, the Doppler effect, and digital sound recording, motion picture sound. But mainly that one is on the periodic sound waves, Doppler effect, and the speed of sound. So then comes chapter 18, which is on superposition and standing waves. This is a big chapter, and it includes standing waves in a string, resonance, sound waves, and standing waves including sound waves, standing waves in rods and membranes, beats, non-sinusoidal wave patterns. Then comes the whole section of thermodynamics, which is part 3, temperature, the zeroth law of thermodynamics, Celsius temperature scale. Turn the page over. Then comes constant volume gas thermometer, thermal expansion of solids and liquids, macroscopic description of an ideal gas. That's chapter 19. Then comes chapter 20, which is the heat and first law of thermodynamics. So which is heat and internal energy, specific heat, latent heat, work and heat in thermodynamic process, first law of thermodynamics, applications of first law of thermodynamics, energy transfer mechanisms. Then comes the kinetic theory of gases, chapter 21, molecular model of an ideal gas, molar specific heat of an ideal gas, adiabatic processes, the equipartition of energy, Boltzmann distribution law, distribution of molecular speeds, mean free path. Then comes chapter 22, which ends the thermodynamics chapters, heat engines and the second law of thermodynamics, heat pumps, refrigerators, reversible and irreversible processes, Carnot engine, gasoline and diesel engines, entropy change, and entropy in a microscopic scale. So that ends the thermodynamics. The next chapter is chapter 23, which is electricity and magnetism, which I have the videos for. So we jump the whole chapter for physics 2 will be still under physics 2, will be light and optics, the nature of light and the laws of geometric optics. So this is measurement of the speed of light, the ray approximation, reflection, refraction, Huygens principle, and up here is the dispersion and prisms, total internal reflection, Fermat's principle. Then chapter 36 will be image formation by flat mirrors. This is a big chapter. Spherical mirrors, image formed by refraction, thin lenses, lens aberration, camera eye, the simple magnifier, compound microscope, telescope. Then up to there is physics 2 ends with that. Now I'm gonna start with chapter 37 is gonna be the beginning of physics 4. Different courses, different colleges do it differently, but here For physics 4, we begin with interference of light waves, which is chapter 37. conditions for interference, Young's double slit experiment, intensity distribution of the double slit interference, phasor addition of waves, change of phase due to reflection, interference of thin films, Michelson interferometer. Then I'm gonna go to chapter 38, diffraction pattern, introduction to diffraction, diffraction patterns for narrow slits, resolution of single slit and circular apertures, diffraction grading, diffraction of X-rays, polarization of light waves. Then I'm going to do chapter 39, which is modern physics, relativity, principle of Galilean relativity, Michelson-Morley experiment, and the whole realm of the relativity topics. So I'm going to have Einstein's principle of relativity, consequences of the special theory of relativity, Lorentz transformation, Lorentz velocity transformation, relativistic linear velocity, momentum, and energy, and mass and energy, and it ends with general theory of relativity. So that's chapter 39. You'll be able to search for that once that's done. Then I'm going to jump back to chapter 34. Some places cover this as part of their E&M. Some places cover it as part of their modern physics. So electromagnetic waves I'm going to cover after relativity, Maxwell equations, Hertz discoveries, plane electromagnetic waves, energy carried by electromagnetic waves, momentum and radiation pressure, production of electromagnetic waves by an antenna, and spectrum of electromagnetic waves. So that's going to be chapter 34. Remember, chapter 33 was the end of the physics 3, alternating current circuits. So physics chapter 34 will be part of physics 4. And then jump back to chapter 40, introduction to quantum mechanics. So this is all the stuff that came after the black body radiation, Planck's hypothesis, photoelectric effect, Compton effect, photons and electromagnetic waves, wave properties of particles, quantum particle, double slit experiment, and uncertainty principle. So that's chapter 24. And then, that's chapter 40. Now chapter 41, quantum mechanics. That's basically a continuation. The chapter 40 was called Introduction to Quantum Physics, and chapter 41 is a more detailed interpretation of quantum mechanics, a particle in the box, particle under boundary conditions, Schrödinger equation, particle in the well of finite height, tunneling through a potential energy barrier, scanning tunneling microscope, and simple harmonic oscillator. Of course, this is all on a lower division quantum mechanics, not the upper division stuff. Then comes atomic physics, atomic spectra of gases, model of the atom, Bohr's model, quantum model of the hydrogen, the wave function for hydrogen, physical interpretation of the quantum numbers, Pauli exclusion principle, and ends with lasers and spontaneous and stimulated transitions. Chapter 43, molecules and solids, molecular bonds, energy states, spectra of molecules, free electron theory of metals, band theory of solids, electrical conduction of metals, semiconductors, superconductivity. And chapter 44 is the nuclear structure, some property of nuclei, nuclear binding energy, nuclear models, radioactivity, decay process, natural radioactivity, nuclear reactions, and nuclear magnetic resonance. So that's chapter 44. Then comes chapter 45, applications of nuclear physics. The chapter 44 was called nuclear structure. Chapter 45, applications of nuclear physics, were nuclear fission, nuclear reactors, nuclear fusion, radiation damage, radiation detectors, and uses of radiation. So chapter 45. And the last chapter in our book is particle physics and cosmology, fundamental forces in nature, positrons and other antiparticles, mesons, the beginning of particle physics, conservation laws, strange particles and strangeness, making particles and measuring their properties, finding patterns in the particle quarks, multicolored quarks, the standard model of particle physics. So it ends with that, and the cosmic connection. So those are upcoming in the next months and years. So look forward for those. Okay, bye-bye.